Hello students, welcome to Young Cubs. We are doing the chapter of electricity and today we'll be learning some numericals related to electricity. So here we go. First come first, we will have to learn the list of formulae that we will come across. Okay, the first one is work. Work is equal to voltage or the potential difference into the current into the time. Okay, and the unit of work is joules. Next, I will come back to the formula for current, but before that let's do power. Power is equal to the work done upon time. So what is work, children? VIT. Yes, we just saw that. It could also be voltage, current and time upon time. So time gets cancelled. So power could also be V upon I. So power is equal to V upon I. Yes. Unit is watt. Okay. Now let's derive this. We just saw power is equal to V upon I. Okay, a derivation where V into I. Okay, if I take V on the LHS, it will go in the denominator, it will divide and I will get my current. So, formula for current, as of now, okay, if resistance is given, there's another formula, but as of now, I, which is current, is equal to power upon potential difference or voltage. And what is the unit? Unit is ampere E. Alright. There is one more formula for energy. Energy consumed. Okay, energy consumed. So energy consumed is equal to kilowatt hour. Alright, children. These are the three or rather four formulae that we are going to come across in the sums that we are going to do today. Alright, let's proceed. From a battery of potential difference 12.0 volt, current 2.0 ampere flows through a wire for 30 minutes. Okay, catch over here, 30 minutes. We will have to convert it into seconds. Find the electrical energy supplied, which is I, by the battery and the power spent. Okay, so let's see what is given. Given is V, that is potential difference, which is 12.0 volt. Okay. Yes, then we have a current, that is I, which is 2.0 A. Okay. and flows for 30 minutes. 30 minutes, as I pointed out, it's a catch. Everything has to be calculated in seconds. How do we calculate it in seconds? You multiply it by 60. 3 6 are 1800. 1800 seconds. Yes, children. Okay. The electrical energy as in work is what they want, and they also want the power spent. All right, let's begin. What is the formula for work, children? Work is equal to V I T. We have V I T. Yes, V is 12, I is 2, and T is 1800. How much does that come up to? 43,200 joules. Yes, so the work done is 43,200 joules. Okay, we also want the power. Okay, power. What's the formula for power? Power is equal to work done upon the time, which is equal to 43,200 upon the time is 1800. Yes. 4 plus 3, 7, 9. So both go by 9. 9 2s are 18. 9 5s are 45. 9 4s are 36. 7 40. 1 second. Let's divide it. Easier for me. 432 divided by 9. 9 4s are 36. 37, 38, 39, 40, 41, 42, 43, 7. Yes. So it's 72, 4, 9, 8, so 48. Yes. 2 1s are 2, 2 24s are. Alright. So power spent is 24 watts. Alright, children. An electric heater is rated 1.5 kilowatts, 220 volts. Find the safe current which can flow through it. Can fuse of current rating 5A be used with it? What must be the current rating of the fuse? One by one. Given kilowatt means power. 1.5 kilowatts. Yes. Voltage potential difference 220 watts. Alright. So what do we do now? So normally we find power in current in terms of watts and not kilowatts. So here itself I am going to multiply this to remove the kilo part. What will I have to do? I will have to multiply it by 1000, which is 1500 watts. Alright. So now we want first thing current. Current is I. Okay. Alright. So what is the formula for current? I is equal to power upon voltage. Correct? Power is 1500. Voltage is 220. Two 11s are 2 7s are 14. 2 5s are 10. So 11 75. 11 6s are 66. 9 0.88. I'll take it up to 1 decimal point. So what's my current passing through this? My current passing through this circuit is 6.8 amperes. Now, can a fuse of current rating 5 ampere be used here? The current is 6.8, children. 5 ampere fuse will easily melt because the heat generated by 6.8 ampere is more. So that's why my answer for B will be no. A fuse of 5 ampere cannot be used. Cannot be used. See, what must be the current rating of the fuse? So it's 6.8, so 7 should be safe. All right. What must be the current rating? The current rating must be 7 amperes. All right, children. Understood this much? An electric geyser of power 2500 watt is used for 1 hour 30 minutes. Find the electrical energy consumed. Children, okay, let's do this first. Given, okay, power is given in 2500 watts. Okay, time given is 1 hour 30 minutes. Okay, we need to find the electricity and the energy consumed. Children, what is the formula for electricity consumed? This one. Okay, kilowatt electricity is equal to kilowatt into hour. Yeah, so electricity is equal to kilowatt into hour. So kilowatt, I have to convert this into kilowatt. So if I have to convert this, I'm going to divide this by 1000, 0 cancel, 2.5 kilowatt. If you want something in kilowatt, divide it by 1000. If you want something in watt, multiply it by 1000. Okay, now I can't use a time like that. So I need to convert this minute, the minute, 30 minutes part into hours again. So 30 minutes is half an hour. So 1.5 hour is how I'm going to write this. So now kilowatt is 2.5 into hour is 1.5, which gives me 3.75 kilowatt hour. Very simple. Energy consumed. Very easy. An electric bulb of 100 watt, an electric press of 750 watt, and a television of 100 watt are used for 3 hours a day. Calculate the energy consumption. So, given is an electric bulb of 100 watt. So, power used is 100 watt. Okay. Then an electric press is also used, 750 watt. Then television also used, 100 watt. So how much is the total power consumed? 950 watt is the total power consumed for how long during the day? 3 hours a day. Correct? Calculate the energy consumed. So now, what do? This is given in watts. I am going to divide this because we know energy consumption is kilowatt hour. So 950 divided by 1000 is going to give me how much? 0, 0, 0 cancel. So it's going to be 0.95 kilowatt, correct? So now energy is equal to 0.95 into 3. How much does that come up to? 2.85 kilowatt hour. That's my energy consumed. Okay, as per 3 hours a day. An electrical appliance of power 1.5 kilowatt is used for 4 hours each day. The electrical energy consumption find the electrical energy consumption in kilowatt. Kilowatt is already given each day. So our day is going to be only for 4 hours. Alright. And then the electrical energy consumption in 60 days at the rate of 6.25 per kilowatt hour. Okay, given, what is given? Power is given in kilowatts, so 1.5 kilowatt. Time is 4 hours. So energy is going to be kilowatt hour. Kilowatt is 1.5 into 4. Energy consumed is going to be 6 kilowatt hour per day, which is as per 4 hours. Okay, then the electrical consumption in 60 days. So in 60 days will be 6 into 60, which is going to be 6 6 are 36 and 1 0. So that's going to be 360 kilowatt hour in 60 days. Okay. Yes. And then converted into rupees. So rate is equal to 360 into 6.25, which is equal to rupees 2250 for 60 days. Alright, children, is that simple? Know your formulas well. Next sum. An electrical appliance is rated as 60 watt, which is the power, and 150 volts, which is the potential difference. Okay, what do you understand by this sentence? So by this sentence, they mean that if an appliance is put into a circuit or is connected to a circuit, is connected to a circuit, okay, with a potential difference, difference of, or with a voltage. Instead of this, you can write voltage also. of 150 volts, it will consume, it will produce a power of how much? 60 watts. Okay, in 1 second. All right, this is what it means. How much current will flow through it? What's the formula of current? I is equal to power upon voltage. What is the power? 60. Voltage is 150. 3 twos are, 3 fives are, which is nothing but 0.4 ampere. Understanding, children? Just basic 3-4 formulas. Learn to apply the formulas correctly and you get your answers. Next sum. An electrical press of power 1.5 kilowatts is used for 30 minutes. Calculate the electrical energy consumption in kilowatt hour and in joules. Given power 1.5 kilowatt, okay, time is 30 minutes. I'll have to change it to hours, so 0.5 hour. Electric energy consumption is kilowatt into hour, which is equal to 1.5 into 0.5, which gives me 0.75 kilowatt hour. Okay, we've calculated this in kilowatt hour. Now in joules, this has to be converted in joules. So in joules, I will have to first make the kilowatt into watts. So I'm going to multiply this by 100. Oh, sorry, multiply this by 1000. I have to remove the kilo, so 1000. Correct? And then the hour. How much is 1 hour? 3600 seconds. Correct? 75 upon 100 into 1000 into 3600. 100 cancel. This gives me 750 into 3600, which is equal to how much? 2700 1 2 3 4 5 6. All right, 1 2 3 4 5 5, not 6, 5. Yes. Now, children, do we know how to, now whenever you give out any answer, you cannot give it out with so many zeros. You will have to convert this whole answer into the standard form. So, if I do it in standard form, can I write this as 27 into 1, 2, 3, 4, 5? Yes. But in standard form, your number, okay, has to be between 1 and 10. So how do I make this into 1 and 10? I'll write 2.7. Because I added a decimal, I will add another 0 out here. 1, 2, 3, 4, 5, 6. Alright. And instead of this, I can simply write it as 2.7 into 10 raised to 6. That's your answer in joules. Okay, children. For standard form, we shall do a lecture do follow our page of Young Cubs Maths Academy, and you shall be clear with the standard form, how to convert numbers into standard form concept. Okay. What do we have next? Assume the electric consumption per day. So electric consumption is already given. Per day is 12 kilowatts. Okay. And the rate of electricity to be calculated by is 6.25 per unit. Find how much cost is to be paid in 30 days. So first we'll have to find out for 1 day. So let me write what's given. Energy consumption is 12 kilowatt hour. Okay, and per unit charge per unit is rupees 6.25. Correct. All you have to do is simply multiply the energy consumed with the per unit charge to find out the charge per day, the cost per rate of electricity per day. So per day cost is equal to 12 into 6.25, which is nothing but 75 rupees. Okay, now therefore cost paid for a month, which is 30 days, is equal to 75 into 30, which is nothing but 2250 rupees. Very simple, very easy. Let's see what we have next. In a premises, 5 bulbs each of 100 watts, 2 fans each of 60 watts, 2 ACs each of 1.5 kilowatts are used for 5 hours per day. Find the total power consumption. What do we have to do, children? Just add up all of them. So total, so my first part is total power consumption. So bulbs, how many bulbs? 5 bulbs. How much? 5 bulbs for 100 watts is equal to 500 watts. Okay. Then 2 fans, 60 watts. Fans, how many? 2, 60 watts. How much does that go to? 120 watts. Fans done. 2 ACs, 1.5 kilowatts. AC 1.5, okay, 2 of them. 2, 1.5, okay, which is 1.5 kilowatts. So I have to convert it into watts. So what I'm going to do is multiply it by 100. Multiply it by 1000, and I get 2 into 1500, which is nothing but 3000 watts. Now therefore total consumption is equal to 3000 plus 120 plus 500, which gives me 3620 watts. Okay, first part solved. Then total power consumed in 30 days. So multiply this by 30. So in 30 days is equal to 3620 into 30, which gives me 3620 into 30 gives me 108600. watts. Okay, now if I have to convert this into kilowatts, 108.6 kilowatts. Yes, children. Okay, now energy, total electric, total electric energy, total electric energy consumed in 13. Electric energy consumed means kilowatt hour. I converted this because you can't, you should avoid the zeros. In physics, you will have to avoid the zeros. So kilowatt, how much? 108.6. How many hours a day? It says 5 hours a day. So 5, how much does that come up to? It comes up to 543 kilowatt hour. Correct? Okay, and my fourth part, the cost of electricity at the rate. So 5 cost is equal to 543 into 6.25 is equal to 3393.75 rupees. Yes, children. Hope you've understood these numericals today. Hope I was able to make this chapter easy for you. That's all for today. Thank you and God bless you all.